We are now going to practice with applying dimensional analysis to word problems. These problems are typically more challenging for students because it always comes down to recognizing where do I start and what do I do from there? Okay, that's what I'm going to go through with you step by step. So I hope that you had a chance to try this on your own, but if not, just follow along with me and hopefully this will help to help you with your thought process. Okay, so let's read this first example. A runner has to run 10 kilometers. She knows her running pace is 7.5 miles per hour. How many minutes must she run? So first thing you want to ask yourself is, what is the question asking me? What is it that we are looking to convert? We know that we have this runner. The runner needs to run a particular distance. What is that distance? You are given the distance to be 10 kilometers. Okay. What's helpful for students is to use colors and underline or circle and things like that when they are reading word problems. So we're going to recognize this as being our given value. Our given value is that our runner has to run 10 kilometers. Okay. What is the question asking us though? How many minutes must she run? So we're looking to change the distance into the unit of time in minutes. Okay, so we need to convert 10 kilometers to minutes. Okay, now, what other information is given in this problem that can help us to figure out the amount of time it takes for her to run a particular distance? We are given that her running pace is 7.5 miles per hour. Okay, so we are given 7.5 miles per 1 hour. Okay, so now we have distance in kilometers, we have time in minutes here. Now, the distance and time that's given in here is miles per hour. We need to figure out how we can connect all this together in order to change kilometers to minutes. Okay, now distance in kilometers and distance in miles has a relationship. That relationship is 1 mile is equal to 1.6 kilometers. Okay, so that's another piece of information that's going to help us connect. Okay, so 1 kilometer is equal to 1 mile, 1 mile is equal to 1.6 kilometers. Okay, so this is going to allow us to change our units of distance in kilometers to units of distance in miles, which then relates to our running pace that we were given. So this will be our first step. We'll begin with our value of distance of 10 kilometers. We need to change our 10 kilometers to miles because our running pace is given in miles per hour. Kilometers to miles. We're going to put our kilometers in the denominator. So if you want to put this over 1, you can. 1.6 kilometers per 1 mile. cancel units of kilometers. Now we have units of miles. What information are we given about the distance per time? Is that she can run 7.5 miles per hour. So now with this relationship, we can flip this conversion factor. So remember, we can treat this like a conversion factor. We're going to flip it because we want miles on the bottom. So I'm going to put 7.5 miles on the bottom here and 1 hour on top. So now what we have done is that we've applied the running pace in order to change distance into time. But remember, our question is asking for minutes. Minutes. We have hours right now. How many minutes are in an hour? There are 60 minutes per 1 hour. That allows us to change our units of hours to give us our final units of minutes. How many minutes must she run? Now that you recognize units have canceled properly diagonally, now we can do our math using our calculator. 10 divided by 1.6, divide that by 7.5, times that by 60. What our calculator is giving us, oops, I think I made an error. 1 minute. Oh, I did times instead of divide. Okay, let's try one more time. Remember, you always want to double check your calculations. Even if it looks right, it's still always good to double check. So I'm going to redo my calculation. 10 divide by 1.6, because it's in the bottom, divide by 7.5, and then times by 60. What I'm seeing in my calculator right now is 50. 50 minutes. Now, the way that I've written this, does this take into account the significant figures? Let's take a look at significant figures. What we have here is 10.0, which has 3 significant figures. 1.6 kilometers per mile, this is 2 significant figures. 7.5 miles per hour, 7.5 is 2 significant figures. And then 60 minutes in an hour, this is an exact value. Okay, there is exactly 60 minutes in an hour. This is within the same this is within the same system of units. So when you're working within the same system of units, then this will be considered an exact equivalence. So exact numbers, we don't consider significant figures. The significant figures are considered infinite for exact numbers. So now 3 sig figs here, 2 here, and 2 here. The least number of significant figures is 2. Therefore, our final answer must be written to designate 2 significant figures. So 50, if we write a decimal at the end of the number, putting a decimal after the 0, this now indicates the correct significant figures for your answer.